It's great to be back in Finland, and I want to take the next 20 minutes to give you an update about all the activities around OPC UA FX. This is the term we use when we talk about bringing OPC UA into the field level. So the activity has been around for overall now 6 years, plus minus. So we did major progress, but we still have some ongoing work to do. So I want to present on these topics. Just a quick introduction. When we talk about bringing OPC UA to the field, we talk about the different use cases and requirements in industrial automation. And this includes certain areas like functional safety, determinism or real-time overall, but also the different domains like distributed I/Os, motion control, field instruments. From the terms, you recognize it's not dedicated to a specific automation domain, but we want to really cover the broad range of applications, so factory automation, process automation, and even beyond. So it's not limited to that, and that's an important aspect. Important is that we divided the work into two phases. The phase one is the controller-to-controller use case, so the horizontal connectivity between any kind of controllers, whether it's a PLC, a DCS system, a motion controller, whatever. And then the number 6, which is then really moving southbound, so to say, from the controller down into the field devices. This is what we name C2D, controller to device, and it also includes the device to device, so direct connectivity between devices, D2D. A few words about the initiative, just shortly. We have a steering committee in place, which is managing and monitoring the initiative. So you see from the logos, we have overall 24 companies, including all the big players in automation, and also including, let's say, technology enablers, hardware manufacturers, also companies with network switches and so on. The whole work is carried out by overall 10 working groups. So you see the diagram with all the working groups and the structure. Also the faces of our working group chairs. When you browse through, you'll again find different companies taking over the responsibility. We have representation from more than 80 companies of OPC Foundation, so membership is required to be part of that. And we count this morning 275 experts that have signed up to these 10 working groups. When we talk about OPC UA FX, it's important to understand and to remember maybe also that it's not a new generation of OPC UA. It's more, let's say, an upgrade of existing OPC UA. So we are not changing anything in an incompatible way. This is why the basis for building an OPC UA FX controller in this diagram is based on an existing OPC UA controller with an integrated OPC UA server. This is the starting point. And then you are adding certain features that we need in order to enable the features for field level communications. This is first of all to add the pub/sub that many controllers already support. Then we have in addition the automation component. It's an information model that we have been creating. It contains a more static part, which is the asset model, and it contains the so-called functional entity. This is where you connect the different inputs, outputs between different automation components. So this is finally where you exchange information in a cyclic way, because we talk about cyclic communication for real-time data exchange or safety critical data exchange. Optional is the OPC UA safety. This is just if you have a device that supports safety over OPC UA, then you add the OPC UA safety as an additional safety layer. Controllers also need to add the so-called connection manager. This is built on an OPC UA client, and this connection manager is responsible to set up all the connections you need to have with external controllers and also, in the next step, field devices. And then finally, on top, you see the offline descriptor. This is an offline representation, so it's actually a file describing your configuration that you want to expose, and that is used by engineering tools in order to, let's say, configure the other controller or the other controllers or other devices. Important is security is something we reuse from the existing OPC UA specifications, so security is built in, and this is important because we are not creating some isolated field bus. We really create an open, universal industrial network. That's why the built-in security is extremely important, and certainly also because of the Cyber Resilience Act coming up. So we are meeting the requirements because building upon the OPC UA security. We look now at the first use case. This is the controller-to-controller use case. So in this case, we look at a plant owner who has the challenge to integrate different machines, very often equipped with different controllers. And certainly he would like or she would like to have this very easily to be done, so easy integration of machines. If we look at how this works in principle, certainly it's an abstraction. I can't go into the details, but you see here now the two machines, machine A, machine B, equipped with controller A, controller B. You see in the blocks down there, this is the built-in OPC UA FX functionality with automation component, the connection manager that is mandatory for the controllers. And now what's happening from the workflow, you have first of all the descriptor of the one controller to be exported by the engineering tool of controller B, imported by the engineering tool of controller A. So then this controller can be configured accordingly. This is the offline part. Next step is the connection manager of controller A as a client is building up the connections by talking to the server as part of controller B. And this is done in order to set up then the so-called UAFX connections based on pub/sub between these functional entities. So this is where we connect the input-output data to do cyclic data exchange. So this is how this works in principle. What is the current status on that? As I mentioned before, this phase has already been concluded. So all the specs to meet all the requirements that have been set up by the steering committee, as you have seen before, are fulfilled since July 2025. This is when we published our maintenance release. We have the compliance test tool available with the additions for testing and certifying UAFX. And we launched about 1 year ago the certification program. This is important because the certification of these products is mandatory. This is because we use OPC UA in the critical operation of a plant, of factory. This is why we cannot just say we trust the suppliers that everything works properly. So we really have to ensure this. And this is why the certification is, let's say, elementary. In addition, since 2 weeks, Stefan already showed the picture at the beginning, we have also got the certification by the TUV for the safety testing tool. So if you integrate OPC UA safety, you can use the existing tool now to also test and certify your safety functionality. So we have prepared everything now to have suppliers bringing products to market. This is the next step. And certainly we don't know the exact timelines. We are pre-competitive. It would be nice to know this. But I would say 2026 is a good year now for having hopefully the first 2, 3, I think this is the expectation from us, controllers that become certified, that are available and rolled out to the market. And I can't mention any names, certainly. That's why I decided to use the one picture of the demo wall that we show since a few years, where it's actually amazing that from all these controllers on the wall, it's actually 16, 9 probably even 10 already have integrated FX as a prototype, so more than 50%. And that makes us really confident that we have this rollout happening in the next year. In the IOPs, in the Plugfests we have seen, there is a high maturity in their implementations. So let's be confident on that. We also have seen just 2 weeks ago some machines at the SPS show in Nuremberg, Germany, where this OPC UA FX C2C has been really implemented in a real application. So you see here a cable robot demo with 8 drives, and you see the cables juggling the ball. So it's highly synchronized. It's also high speed. That doesn't mean the drives are connected yet with OPC UA FX. This is for sure still some proprietary or field bus connectivity. But the 2 controllers that you see on the right-hand side in the cabinet, one from B&R, one from Schneider Electric, they use between themselves the OPC UA FX C2C. So every controller actually controlling 4 axes. So amazing demo that caused a lot of interest during the show. All right, in the next part I want to talk about now the next step. Next step is now going into the field devices. So we want to enable machine builders, kit builders to connect all the periphery in the machine with OPC UA FX. And this is building upon the concepts we already have released, but we need some additional elements, and I come to this in a second. The purpose of doing this is actually not only to use OPC UA for now the real-time critical, safety critical operation. Because we are building upon OPC UA, it means that also OPC UA is built in for the other use cases. So we make available all the information in these field devices to connect to an edge application, to even deliver data up to the cloud, because it's built upon OPC UA. So as Stefan mentioned earlier, we want to really have the model directly at the source, ideally, and not just, for example, in a PLC that is acting somehow as a gateway, but really have a direct connectivity to the field devices. So how does this work? Again, I used a similar picture as you have seen before to make you understand it's the similar concept. In this case, it's not 2 controllers. We have 1 controller on top, and just to make it easy, 2 devices. Each device has its representation with the offline descriptor, device 1, device 2. The workflow is the following. We have first of all the engineering part. So the engineering tool of the controller importing the descriptors for all the devices that it should connect to. After the configuration is done, we have the controller doing now the online part. That means the built-in connection manager is initiating the connections with these 2 devices. And this is in order to set up the so-called C2D connections, controller to device, but also, this is implicitly part of that, the direct device-to-device connection. This is just done with the same mechanism. So as you see, it's building upon the concepts that already have been defined for C2C that somehow accelerates now the creation of specs for the C2D, but we have some other challenges. I come to this in a second. Explaining a little bit how this works, I call it a profiling methodical approach. We already have released, as I said several times, the controller profile. This is a fixed specification, exactly one for any kind of controllers. And it includes certainly all the FX core features you need to have in order to make this work. Now, the methodical approach is the following. Currently, we are extracting from this controller profile all the elements that are generic and are, so to say, mandatory for any kind of FX implementation. And with that, we are rebuilding the controller profile So it's actually not being changed, it's just described in a different way because we are building upon the so-called component facet, which is bundling the FX features and adding then those things a controller needs to have in addition to that. The same component facet is actually the facet that we then also apply to the different field devices. So it's the same basis as for the controllers. For any kind of device, whether it's I/O, motion device, instrumentation. But in addition, we are defining, and this is one of the challenges we have, a so-called base device facet, which is including all the generic features that devices have and that are not unique to just being a motion device and I/O device. And this is a harmonization that is more complicated than we expected because we have experts from different domains. They need first to understand each other and then agree on what is put in the generic part and what is then unique to the specific devices. So this is a big challenge right now, having agreement on this base device facet. The nice thing about this component facet is that it's also helping us to create other kind of FX implementations. I'm just looking at Uni because we were discussing how FX might also be included into Forge. Because once you have the FX mechanisms built in, you can directly get the data out of all these devices, whether it's a field device or the controllers. And also, it's helping us to build gateways because suddenly we have controllers not yet supporting OPC UA FX, but using this FX component facet could help to build these gateways for brownfield. All right, the other challenge we have is the transport. Because we have a broad range of applications, right? Some can do with lower performance, so to say soft real time, but we also have applications that need high performance, fully synchronized behaviors. So far we have concentrated on the pub/sub over UDP IP, which is not so performant. This is why now in the next step, in the prototyping for C2D, we are looking into the direct mapping into layer 2. This is here the number 3, which reduces the overhead in the transport. It allows us to reduce the cycle times in order to achieve higher performance in the network. And then finally, we can scale the so-called quality of service by adding elements out of IEEE 802.1. This is Ethernet and Ethernet time-sensitive networking, so the deterministic Ethernet. And we have a scalable approach how to add certain features to increase the quality of service in order to even support a fully scheduled network where you have reserved bandwidth for the different types of traffic, critical traffic, less critical traffic, or best effort traffic. So 1 and 2 is already tested because it's part of C2C, and the 3 and 4 are now important for the next phase. Okay, just a few words about the demo that we have shown for the first time at SPS show 2 weeks ago. This is now the first step into the C2D. We have shown different targets from different hardware manufacturers, Analog Devices, NXP, Renesas, where we have already ported OPC UA FX stacks into these boards with different operating systems. We have been showing the C2D with a central controller, Intel-based with a connection manager, at the same time in parallel, a direct connectivity up to an edge application bypassing the PLC. This is, as I said, a big, let's say, benefit of OPC UA FX. For next year, we plan a big demo wall, also similar to the one you have seen with the controllers, including field devices of the different types. The call is out right now with the newsletter, and we are now collecting all the interested device manufacturers. Coming to the end, Uni. If you're interested to learn more about this moving from C2C to C2D, it's an interesting recording in YouTube channel of OPC Foundation. Our chairs talking about now what is going on and They are quite motivated, as you will see. So I think it's interesting to listen to that. I have some QR codes for you with different brochures that we published already, learning more about OPC UA FX. And the final slide is my contact details in case you have any questions to me. Thank you very much.
Thank you very much, Peter.